Welcome to myprojectbazaar.com. Our project title is Reliable and Efficient Data Acquisition in Wireless Sensor Networks in the Presence of Trans-Faulty Nodes. Abstract: a collection of spatially distributed sensor nodes in a wireless sensor network work collaboratively to sense the physical phenomena around them and then send the sensed information to the sync node through single hop or multi-hop paths. In this work, we propose a scheme named Readme for reliable and efficient data acquisition in the stationary WSN in the presence of trans-faulty nodes. Due to the trans-faulty behavior, a sensor node gets temporarily isolated from the network. Temporary nodes isolation leads to the formation of dynamic communication holes in the network, which form and disappear dynamically. Furthermore, they may increase or decrease in size dynamically as well. These effects results in loss of information in the radiation affected area. To prevent information loss in WSN due to trans-faulty behavior of the sensor node, in the proposed scheme, we construct the network using sensor nodes having the dual mode of communication, radio frequency and acoustic. To get redundant coverage within a radiation affected area, all the sensor nodes in the area become activated and switch to the acoustic communication mode after detecting themselves to be affected by radiance. In network, data fusion is performed to get actual information from the redundant information received from the radiation affected area. Simulation results exhibit that the proposed system Readme achieves better energy efficiency and reduced average end-to-end delay than a sensor node having only acoustic mode of communication. Let us see the flow of our project. First, network is formed. Our network model consists of 1000 cross 1000 region. So in that network model, we have to sense the range, that is our communication range is set. Then we have to identify that boundary, that is bound hole identification based on the centralized boundary node detection scheme. In that scheme, we have to identify that holes. If that boundary is detected, then we have to translate, we have to identify the fault nodes. In this, fault nodes are identified using this radio frequency. The node which have the less radio frequency is identified as fault node. So we have to send the data via the active nodes. The node which is active, we have to send that via that active nodes. The fault nodes are rectified. Then the performance evaluation is done. Performance evaluation is calculated based upon the energy, throughput and delay. Let us see the output of our project. First, we have to open the terminal window in this VMware workstation. Then change the directory. Then type ns main.tcl for running our TCL code. Our node is set 100 nodes in the region of 1000 cross 1000, and we have to calculate the distance between all the nodes, and we have to define that routing and discovery process. This is our route discovery process. There is a routing table is generated. This is for our source node, and this is second column is denoted of our time, and third is for our destination, and for this is for our ending time, and this is for our flag value. The output window is called network animated window. When we click on this play forward button, it will start our simulation. Our network consists of 100 nodes. This is our source node and this is our destination node. Now the infected nodes are identified using that centralized algorithm. Our concept is also have a sleep and wake up concept. So the node which is transmit the information is set to yellow color. So that is in wake up state. All the other nodes are in sleep state for gaining the energy efficient data transmission. So the infected node, which is drop the packet, so we have to identify another path for sending the information. We also identify the void problem. These beacons tells about the communication range. These dotted lines represent the TCP connection. For running our graph, there is for identifying the performance evaluation of our proposed redist. Type xgraph space delay.xgraph xg. This is our delay. This is our proposed delay graph.